to a deeper explanation about the system and to say what we are doing. You can see here a cell, then frequencies from our devices are coming and then stimulating the cell structure, yeah? And with this stimulation, we can then speed up the cell metabolism. And you know, when you have children, when they have an injury or whatever, the healing time for that is mostly very short because it's very fast. They have a very fast metabolism, yeah? And when you are getting older, this metabolism gets slower, yeah? And this is exactly the point why our system is working so well, because we are able, and this is the result of more than, I would say, 35 cell biological studies, that we can speed up the cell metabolism and also the cell regeneration, yeah? And that's really great, yeah? Okay, yeah, and that's, of course, the explanation how our system is working. It means with our frequencies, we are able to stimulate cell structures to higher the cell metabolism and the final end to have a faster healing. Yeah, and when you, this is of course, I would say a mock-up. It is a video presentation. In real, it looks in this way. This is a time-lapse video with, here, this without bioresonance, and this is with bioresonance. This is a cell regeneration video, time-lapse video from 24 hours. And you can see here, under the influence, the wound is closed, here not. Yeah, and you can repeat that all the time. It works exactly in the same way. Yeah, and that's exactly the point. That means we are stimulating the cells to have a higher cell metabolism, and at the end, because of this higher metabolism, a faster cell regeneration. Yeah, I will come back to this point also when we are talking about the Rayo Aqua, because this is directly related. Yeah, and this is for us so important because I need for the validation in the thesis a method to show that what we simulated worked really in reality. And therefore we used this kind of cell regeneration time-lapse videos or the cell metabolism in general to show and to validate our calculations. And you can see here, this is, and I'm really very happy about that, this is the university, the brand new university in Pilsen. The university is an electrotechnic university, Rice, yeah, and this is an original picture. Here's my car. Yeah, yeah. And we started in a way that it was, believe me, it was so strange to come with this thinking into a very traditional university. Yeah. And I remember very well when I opened at first a PS10. I showed them, this is a device, a medical device, which is working, and we do not know why. Yeah? And we want to find out the reason why it is working. Requirements, of course, of the doctorate before we started really deep with the device. And then we created really the mathematic and the electrodynamical structure of our dipole antennas. And I want not to make here a lecture for physicians or so, yeah, but only to show that we are really now able to explain, yes, how the system is working. You remember in the polar were dipole antennas, yes, like these ones, yeah. And when here, when we are having on this dipole antenna a potential difference in the electrons, like this one here, lower, here more. Yeah. Then we are having here on this dipole antenna, because of the potential difference, an electric field around the dipole antenna in this way. Because no current is flowing, we have no magnetic field. Then in the next point, these electrons want to go back, yes, to the other side. And therefore the current is maximum, but because we are having no potential difference, we have no electric field, and therefore this electric field is leaving the dipole antenna. And because the current is there, the magnetic field starts. And then we have exactly the opposite here and that way, to this time period here. And in the same way, the electric field is created, no magnetic field, but now it is exactly the opposite. Yeah? And then the way back. And you can see here that from the dipole antenna, the electric fields are leaving. Yeah? And when you are looking to a simulation which is a little bit faster, you can see it in this way. Yeah? That we are having here a dipole antenna, and you can see here like how the frequencies are leaving the dipole antennas. Yeah? And this explains completely, and I'm not sure that I'm having that here, because I can show that a little bit later to you, because the doctorate is divided. It took 4 years, and it is divided in the first part to create in the first, they called it small doctorate, all the fundaments to go over then to the real goals of this study. And all the fundaments are developed, and we can show now exactly how the mini Rayonex is emitting the frequencies. And I remember, well, Thomas, you know that also, when we talked about the mini Rayonex, yes, say, how does it work when I'm taking this in this way? It's not working, and then we have a west-east direction, and whatever, yeah? And now we simulated, yes, with COMSOL multiphysics, exactly we created there the dipole antenna, exactly what is in the device, and then we showed how is the emitting structure, the emitting characteristic of the radiation. And you can see here, this is the mini, yeah? And around the mini is, I would say, a toroid. That means, easier to say, like a donut, yeah? A donut structure. That means here around is exactly the field, and the field is around 2 meters. Yeah, that means when I'm having that here, I'm having it 1.87 meters tall, is exactly in the middle, therefore I can exactly stimulate the whole body. Yeah? This is the stimulated area. And this explains all the things we can't answer in the past. To say, is it important? Is there a difference, or to use it in this way or in this way? No, there's no difference, because it is exactly the same. You can see here, it is around. Yeah? And when you are using that, for example, in the pocket, you have permanently your body under the influence of the mini Rayonex. Yeah? This is now completely to explain. And another thing is it really true that a PS10 or a polar can change the frequency when the dipole antenna is turned? We said yes, because of our experience, but there was no mathematical equation behind to show, yes, it is really doing that. Yeah? It means for the practical usage, it is not important, but it is the fundament. And when we want to grow with bioresonance, according to Paul Schmidt, we have to answer these questions. Otherwise, we cannot grow, because they are saying, what you're doing is crazy. Yeah? We had, I would say that, we had a very nice physician in Germany, I think 15 years ago, 20 years ago. There was a TV show, and they had an old Ryometer PS10 on the table. He opened the device, saw the dipole antenna, and said, "Here, look like it cannot work." And he did it in the rubbish in the TV show. Yeah. Okay. In the meantime, we know this physician was not very clever. Yeah. And but to argue against these forces, against these people, this is so important to say. Then you are not sure how the system is working. Please read the doctorate, and then it's fine. Yeah, that's the idea. Yeah, and then to say, doctorate, mathematical, physical, electrodynamical explanation is there, how the system is working. We are having an in vivo study, yeah, gold standard study. We are having more than 30 cell biological studies, and all the research, and hopefully in the future an own master of bioresonance according to Schmidt and whatever. Yeah, this can be only done when we are having this kind of fundament. Yeah, and in the meantime, my feeling is that we are going down from the hill. That means we are having now the answers, and what we have to do, or what I have to do now, is to write everything together to the final doctorate now. Yeah.
Can I ask one question, please? If you're going back to the previous slide, showing the change of the polarities there, so how often does that actually occur in a certain time frame?
Yeah, that's a good question, Thomas. This is this is a point normally humans cannot imagine. Yeah, that the mini Rayonex or the Polar or the PS10 is working in a frequency spectra of more than 1.5 gigahertz. That means 1.5 billion times in a second.
Incredible.
This is changing.
1.5 billion.
1.5 billion, times in a second. And we are.
This is really a slow.
Yeah. Yes, this is really a slow motion. That's really true. Yeah, that's true. And therefore unbelievable. And this is the reason that so many people are hesitating to come in touch with that, because it is not to imagine, not explainable. Yeah, but that's the way. Yeah, that's the way how our world is working. Yeah. Okay. Let's see another thing here, and this is only a very short part. We did so-called simulation studies. Yeah, that means you can see here a dipole and a turning dipole over the first one, which is fixed. And when you are here in the PS10 or in the Polar, the noise, yeah, then exactly these dipoles are fixed in an exact position. Yeah, and one of the goals is to show, or to show not, whatever, because it is open. Yeah. That the system is really able to change the frequency spectra, the resonance frequency spectra, when we are turning the angle of these different dipole antennas. Yeah? Okay, what I'm telling you is very theoretical. That's the reason why we are having Ms. Bunkenburg to explain to you everything practically. Yeah, in the second part. Yeah, but believe it or not, it is really true that when we calculate this study here, the resonance frequencies and also a little bit here the radiation structure changed. That means when Paul Schmidt developed that in 1975, he had definitely no knowledge about the mathematical basics. It's impossible because no simulation software was existing at that time. Yeah. But he worked it out with the Raya tensor, yeah, and he worked out everything in the basics. That, yeah, this is this way, and we have to say now, he was right. He was right. Yeah, it's unbelievable. Yeah, fantastic, really. Yeah, totally impressive. And that we are now today are able to show that he was, with his measurements, totally right, is, I think, a honor, yeah, for the system. Yeah, that's really, really very, very interesting. Yeah, and by the way, the question of the source. What is the source that a dipole antenna system in a mini Rayonex can work without an external energy? This is, I have 3 goals they gave to me from the university, and one goal is to work out a structure to explain why this dipole antenna system can resonate frequencies. Yeah. And I have to say, in the meantime, we know how it's working. And we know the source. But I cannot tell you the source, because we have, the patent is pending. Yeah, and we are working on that.
I was just going to ask. What is the source?
No, it is really so interesting. I just at the last weekend I wrote this part in the doctorate, and we measured in 2 different incubators where the cell biological studies are working around a mini and around and with a cell biological with a cell film on top. We covered it with an aluminium foil to cover it against external frequencies. So that and that was very important for us to show what can be the real source. Yeah, and therefore we have now the answers. And I think next time when we are here, or whenever, we can show to you how it is working. But the answer is, it is explainable. And that is for us the most important thing. Yeah, because we were so yeah, when we started the discussion and the workout for that, the devices are used in the 56th floor in Hong Kong in a skyscraper in the same way than in the basement. They used it in the car during the drive. Yes, they used it on a ship or whatever. Yeah, it means totally different environmental conditions, but the system is working. And this is crazy. And it is working also in a Faraday cage. And this was unbelievable. What can be the source? Okay. Yeah, but it makes sense to go deeper in the technical part and to explain these things and to find the fundament. And we found the fundament. Yeah. Okay. Only one thing. To come over to the final doctorate, I had to pass a state exam on that university. And there's a very strong rule, not strong, this is a very clear rule. 8 professors are sitting around the table, 2 of their own faculty, yes, 3 of their own university, and the other 3 from external universities, yes, and they are asking then the questions, yeah. And when they heard, it starts with the way it was 30 degrees, it was really hot, and I asked to bring it to take it out. Yes, and I said, no, a little bit later, yeah, because very strict, very strict. It was so, yeah, it was full of rules, yeah. And then I started the explanation that we found the effect and the validation that frequencies are changing the behavior of cells. Wow, they were shocked. Yeah, they expect everything, but this was a shock for them because they are teaching to their students that frequencies are not having influences to human cells. Yeah. And now Dietmar Heimes came and said, it's exactly the opposite.
That's a big deal.
It was not a deal. It was crazy. Yeah. Normally, after the presentation, and it took around 5 hours, they they came together and discuss and whatever. And normally it took 10 minutes, yes, but it took, I think, 45 minutes because they were really arguing against that is this really possible and so on. And therefore, I got a long list of things what I have to do to show that we are having really a robust measuring system behind. Okay, at the first it is a new hurdle, but now I'm totally happy that they ask for that, because now we know, by the way, because of their question, what is the source behind. Because of this question, we found the answer.